Got myself on mute. Oh my gosh, so many things. How is everyone doing today? Oh my gosh. So Streamlabs reset. I see there's already some questions, which is awesome. Streamlabs reset, and I had to do a whole bunch of changes. So I was like, okay, getting everything fixed up. We're going to be fine. And then I go, and it's like, things aren't streaming. Another beautiful day in Knoxville. That's what we love to see. Can everyone hear and see me right now? I think everyone can, right? Good to see you, Allie, Miranda. I see there's already a question. Allie, too, has a question. Great. Kayla can see me. Awesome. Everyone can see me. We got some 320 questions. We got some, and I reset the computer. I did all these things. Good to see you, Alexander. Good to see everybody. I saw there's like 7 or 8 people watching, and I was like, oh my gosh, we got to get this going. We got to get the office hours started. We got our studio starting up. I think there was a question that looked, we got this. Can we go over the Greek symbols and what they stand for? Is there a list of all the Greek letters we have used so far in Stats 1? Let's go ahead and do that first right here. And I think Ali has a question about 320. For assignment 3, task 2, my spearmint interval was inclusive. Does this count? Also, I know it has increased the permutations to 1,000, but I have increased to 5,000 to have a conclusive interval. As long as it knits, if it knits, that's fine. And if they take out points, just tell me. That's fine. Because it's the idea of it, Ali, is that you just understand what inclusive intervals are versus intervals that are not inclusive of the 0.05. Does that make sense, Ali? I know it's already Thursday. That's insanity. Like, tomorrow I mainly just have meetings. We're going to have a huge Kahoot for Stats 1 on Sunday. So I'm just like, I can't believe it. My mind is blown. Just insanity. Just absolute insanity. I think we got Word up. Okay, let's go over to Word real quick. Okay, let's do this. So here we are with Microsoft Word, and so we could use either one's fine. As the big thing, Ali, is just to know when if the interval. Here we'll mention this briefly. So I'll remember to put this in the video here, like that we were talking about it. When you have p-values, then we'll do notation next. And this is only for p-value intervals. So a lot of people later on in the class, if we do an interval, might say that the interval is inclusive. And I'm like, well, we're not doing a p-value interval. So only when we do p-value intervals do we want to talk about the interval is exclusive, which is a good thing. Well, at least for the conclusivity of an interval. Like these intervals right here are all exclusive. They exclude the p-value, which means they conclude to a result. But these intervals right here would all be inclusive. And so what is the key value when we look at p-value intervals? When we look at p-value intervals, oh, Mubot. Wake up, Mubot. You just broke the world destroyer, Mubot. Sorry, I was getting everything going and I didn't wake up, Mubot.
I am Mubot.
Where are you, Mubot? Mubot. You should wake up. Wake up and talk to us all, Mubot. Oh, Mubot's awake. Mubot is officially awake now. Sorry about that. Exactly. And so the way I usually, not that I try to trick people for the test, but usually the problem I usually see is people think of like 0.50 a lot of times as like, because just 0.05 and 0.50, I see how that can get confusing. Mubot forgives you. Mubot forgives everyone. Nothing he's tricking. He needs some extra Z's. He was passed out. And and so this has nothing, like this value right here, the 0.50 has nothing to do with it's a very high p-value actually. So don't ever think of that value. We really only care about the 0.05. And like this interval right here, which is going to be conclusive, might go from something like 0.48 to 0.72. That's a very wide interval, but we're saying we think the p-value, just think of it this way. Like if someone said, what do you think the p-value is? And like, let me ask this, or let me make it this way. What would probably be the estimate of the p-value if you ran your results? And we haven't done a question like this, but if you ran your results and got this interval that I'm highlighting right here, if you ran your results and got this interval that I'm highlighting, sure, green on green works apparently. If you ran this result and got this interval, what do you think the p-value you got for the interval might be? What do you think your p-value for the interval might be if this is your lower and upper for the interval? Like you're saying, I think the p-value is probably between 0.50 and 0.70. So what was your estimate probably of the p-value? Exactly, Ali, you got it. That's exactly it. And so these intervals are usually symmetric. They're not always, especially the way we do them with this, but they're going to be somewhat symmetric. Exactly. The p-value is probably going to be about 0.60, and then it's going to do like a plus or minus. They're not always symmetric though, but no, like that's exactly what I would say. So your answer is exactly, but I don't want everyone to think it's always going to be symmetric. But the estimate of the p-value is usually about in the center of the interval, and then you're going to see the lower and the upper go down a margin of error from it, usually about a symmetric. But the way we do it with permutations, it doesn't always make a symmetric interval. So does that make more sense? I think you understand it quite well. So basically averaging them together, great question right there. This is what's really good, Alexander, is, I was almost saying Andrew, I was like, it's Alexander, is that when you do this in 201, if you take the upper and the lower and divide by 2, you will get the center of the interval. So this will, so in our expression, which is by, yeah, exactly. You'll just talk about the interval you have, and you'll just talk about it either it's inclusive of 0.05 or it's exclusive of 0.05, which means all these intervals come to a conclusion right here. These intervals cannot conclude whether it's statistically significant or not significant. It's just the main thing to understand from this concept. It's not, I don't, like, does this, hopefully, Ali, like, it makes, like, you're like, yeah, this makes perfect sense. Like, if it were to contain 0.05, we wouldn't know if it's statistically significant or if it's not statistically significant. Yeah, yep. There's probably things, it's, we'll be talking a lot about statistical significance in 201. And so this is a good concept for 201 also, because anything below here is statistically significant. And anything above here, maybe we shouldn't do that in green because it might look like we're talking about, like, so anything below here is statistically significant. And anything above here is not statistically significant. So everything above here is not statistically significant. So it's okay if the interval is inclusive. No, and I think that's the point for task 2, right? Let me look at task 2. Let me look at task 2. Here's update. Let me, sure. Task 2, okay. The p-value for an interval tells us whether or not a test is statistically significant. In some instances, the test might come back with an inclusive interval test, inclusive interval. Run the associative function on 2 quantitative values and find a test where the interval is inclusive. Yep. This is just an instance, like, just to show that we understand what it is. For my variables, the Pearson interval was conclusive, but yeah, and that's fine. That's that can happen. So one of the tests might come back conclusive, but the other one might, and you could mention that. You could say, like, while the Pearson is conclusive because it does not contain 0.05, yeah, this is just for task 2, and you don't generally want this. Does that make sense, Kayla and Allie? You don't generally want this. This is just something that can happen when you run a test, and we should know, like, how to look at the results and be like, okay, this was a conclusive interval or this was not a conclusive interval. So we're just kind of making the results happen. And I think, Ali, you were mentioning in Discord, and really great questions. Thank you so much for everyone using the Discord, especially 320. And I think more people are talking to the TAs now, which I love, that people are like, hey, are you free? And the TAs are like, yeah, jump into room 2. And has anyone here, Kayla, Ali, talked to the TAs, like jumped into a room or met with them, because they look to be helping out a good bit, which I love. I'm just like, awesome. People are working with the TAs. And then to make it conclusive, I had to put your permit. Yeah. And then just make sure to have a set seed, because when you set seed, you'll replicate the results. So you should get the same results when you knit. And it's all right if you have to increase them a little bit. You can mention that. If they take off points, just tell me, because, and Kayla's been a huge help. Kayla's just rock star on Discord. Everyone who's working and talking to each other and helping each other with the assignments, really, really helpful. And I hope to build that community more in 201. It's so interesting because 320 is smaller, and but people are like working together. I haven't gotten into a room with them, but yeah, exactly. You can do whatever you like. You can send questions. And I'm really happy just with the communication, because it looks like the 320 TAs are getting some good work with assignments with students. More questions. If you have more questions, let me know. If I have an inclusive interval for a different task, do I analyze that or change my permutations of the values? You could just mention it. So when you think about this, this is not like, let me mention this. If you were doing research, I would definitely increase the permutations. With this right here, with this assignment, this is mainly to just understand the concepts and to talk over them and to, like, make sure you understand what an inclusive interval is, what this is what we did yesterday, right? Yes. To understand the concepts. So don't worry about having to increase it. You could mention that in your report, but as long as you're following the guidelines of what you need for the assignment, you'll be good. So you don't have to change it, but Yeah, don't worry. It's just if you were doing this for like an actual report or something, I would increase it. But the point of the assignment is just to like understand the concepts. So, an excellent work. And really good questions right there, Kayla. Like I would definitely, if I was working on something, I would increase the permutations. As right now we are uncertain of the statistical significance. That's what a interval means that contains 0.05. More questions on 320. 320 is going to be very happy with task 2 has now been put into video format. You're welcome. You're welcome, Allie. And or maybe I think you're thanking Kayla, who's just it's just really great. Like it. And I just want to say this: all it takes is a few students to be super active on Discord, and like I think we have like maybe 3 or 5 students right now, 3 to 5 students who are pretty like using it. And I think other students are benefiting from it because they're looking at the Discord conversations and seeing the questions that are asked and answered, and it's causing other people to go to like a medium level of interaction, and it's raising up the whole class. So the both of us, so it's really, Kayla, I just have to thank you you're one of the big reasons 320 Discord's going so strong right now. So and then Allie's helping it out, and we're just raising everyone up. So maybe mention the further analysis with the criteria required for more conclusive results. Yep. So when we look at the further analysis right here for this task, when you run the associate output, so I shouldn't code it there. Here, we did it here yesterday. What do we have right here? We have all correlations. Let's put this away. Associate. What do I have down here? I don't think I have data loaded in. Oh, Bulldozer. Cool. So this is when you load data Bulldozer. This is going to come back with an extremely conclusive result. So how do we know figures are too large? How do we know if something is conclusive or inconclusive? We have to look at the following right here. For test 1, could you point out which p-value to use? I'm using the averages one. If that's for means. Yep. So if you're, and I'll show this real quick right here. I have survey 11 loaded in. Almost got survey 11 loaded in. The big thing, survey 10. There we go. Know your variable names. So the big thing is knowing which one do you. So in this instance right here, because of this down here. So the options we have for this, it might be hard to see, but that says averages, that says mean ranks, that says medians. And so the biggest thing for task 1. So I don't think there is a means p-value. I don't think there is a means one. Because you see right here, you might be are you talking about this right here? If you're talking about this is not means right here. This right here is not means, it's mean ranks. It's a Kruskal-Wallis. We're not going to do the mean ranks. It's just extra output. So don't use this one. Whatever you do, don't use this one. That's mean ranks. This right here, it says averages. It's very small to read, but if you see it, that says averages. And so this is the averages, which is the ANOVA, and the ANOVA is the what? This is the first of the 3 output. Yeah, no, great question, Ali. Once you see it, you're like, okay, this is the first of the 3, like 1, 2, 3, 1, 2, 3, and then right here, 1, so that's the means, 2, and that's the Kruskal-Wallis right there, the medians, and that's the 3. So as you see right there, so Kruskal-Wallis, so the mean ranks. So, and even here it says ranks. I can see how that's a little bit confusing, how here it says averages ANOVAs, and here it says ANOVA means. Here it says Kruskal-Wallis ranks, and here it says medians. Or no, wrong one. Here it says, that'd be really confusing, mean ranks Kruskal. And so we never mentioned the Kruskal-Wallis, but it does have the word mean right here, which could be really confusing because it's the only one that says means. It says means more than this one says means, but the ANOVA is the means test. So you'll use, if it's normal, you'll use this. But in this instance, because of these outliers right here, in this instance, I'd probably use medians, but look at your output. Either way, it always comes back statistically significant for this. There's a very large difference between genders and the heights of individuals. I think we did heights, but that's not the one you're doing. All my intervals come back conclusive right here. I could probably make an inclusive interval if I chose something that, let's go to survey 10 real quick, and then we'll head over to 201, and we'll talk about the types of variables, or the notation. Notation is very important. Wait, that's not what I want. Oh, I don't have it attached. Let's go to attach so I can get my autocomplete. Great questions this morning, everybody. I feel like I need a second cup of coffee. All right, how does this one come out? So here's the thing, and I will allow this. So take note. Well, one, let's do a few things. Let's go to permutations. Let's set them to 200. And then let's go to what you could do. Here's another trick. So here's a few tricks to get. Don't set the. I know. Don't set the permutations to 1 because that's too easy. So 202. No, let's do 100. I would not set lower than 100 because then you're just making it too easy for yourself. Oh, really? The results are coming back very similar each time. Oh, there we go. Here we go. Look at that. But we wouldn't use the means. I mean, you could mention that. If you take a look at these results right here, this is a very inconclusive interval because it comes back with the p-value is in 0.05. Does this make sense? I think Kayla was asking about this. And so when you have to do the further analysis, Kayla, you will increase the permutations. Now, one thing I want to point out is when you do the further analysis and you put it to something like 1,000, which should come back conclusive for most, make sure to have a seed so that way your results are replicatable, but then we are putting the plots off. So this time when you do it, it won't make plots. So if we had cleared out this output, it won't make the plots. Just since, we've already seen the graphics and everything, we're just going to not fill the screen with multiple things. Does that make sense, Kayla, that the first time you do it, well, one, make sure to use seeds as always to replicate results. It doesn't matter totally what seed you use because you're just controlling your randomness. Graders shouldn't take points off if you choose like a seed that's not current year. Current year is just a good seed to remember. We're not, because we don't pick a seed to find a result we want unless we're trying to like show something. Like I purposely, someone could be like, well, Brian, didn't you just like search for a seed that did what you wanted? I'm like, yes, because I'm trying to show an example of something, which is kind of the point of the assignment, to find something. And now with the seed right here, when I run the results, I will get the same interval, which came back inconclusive. So this result right here is replicatable, but if I didn't have this seed right here, if I put an NA, which just means there's no seed, does not apply, we're not going to get the same result. We see the intervals I was getting before, and it would be pure luck if when I do my assignment, it comes back without a seed. Yeah, and that's why we use seeds, because I'm not going to get the interval that's inconclusive unless I just hit lucky. Man, I got really lucky with that one. It's a different interval up top, but it's even more. Oh wait, no, that was an inconclusive interval. So I did finally get lucky. But no, these are just all random right here. And if I do get one that's inconclusive, it's due to luck. So, man, I just want one more. This is now off as, oh, there was one. Okay, cool. We'll go with that one. That's the medians, which is actually the right test for this, which is maybe better. You'll still get full points either way. The median would be the test for this. And why is the median the test for this? What plot do we look at to determine means or medians? This should be pretty instantaneous for 320. And 201, this is also a review of 201 topics, because you know this by a different name. You know this by a normal probability plot, or the plot that shows the probability it's normal. So the QQ plot, yep, Ali, like, is that, hopefully that's instantaneous right now, where you're like, oh yeah, you just look at this and you see if it follows the red line. Doesn't follow the red line. That means we're using medians right behind Brian right here. QQ plot, not normal, exactly. So the QQ plot shows that it's not normal, so we're going to use medians instead of means. You can also see it up here in the histogram, but we always look at the QQ plot. And once you've done that like 5 or 6 times, you're just like, oh yeah, just look at this plot right here. Follows the red line, normal. Doesn't follow the red line, not normal. And yeah, so excellent work. I feel like this is the stuff that's on the test. Like I show this and I say like, which of these graphics, like when I have written tests, I have someone write out, I say like, use the following, circle the plot that you used. And do you know what plots usually people circle to tell them whether or not it's normal? A lot of people will, one, they'll either circle the histograms, which that's not the worst, or they'll circle the permutation test down here. They'll circle these and they'll be like, these down here tell us. Because usually I like to pick one that's more normal, and then they'll, like height I think was more normal. So I'll say like, which of these helped you decide? And they'll circle these down here and say they're very skewed. So, or sometimes I'll even remove these histograms and be like, use the following output And this says like if it's normal. So I just know a lot of people look at these and don't know what these plots mean because this is your result. These are the results created by random chance, and the p-value is right here. Which another test question I always put on, like this is a classic test question. It just says this. We take this, and oh no, we can't do that. Here's a test question. We're gonna go right to 201 right after this. But I know you guys are gonna get this. Here's the test question. What is the p-value? Enter your answer to 3 decimal places. So what is the p-value for this? Answer to 3 decimal places. And I believe, don't worry if you don't know it, that's not the end of the world, but I believe both 320 students in here right now will get this pretty quickly. What is the p-value for this? And enter your answer to 3 decimal places. What is the p-value? Kayla, that's basically, yeah. You could just enter what, though? You're totally right. That's a great way, like, scientifically to put it. Because that's to the 3 decimals. What is Brian probably wanting most students to put in? That is like the above. I really like that answer because that is like down to 3 decimal places accuracy. It's definitely less than that. I totally agree. And so I'm probably wanting what? Which that would be if it's a written thing. I probably would. It's going to be less than that. I would say. What I would want is because remember. So let me graph what the p-value is. This is the p-value over here. I know because you can't say something is impossible. Okay, wait. I'm throwing 50 points. Kayla, the way you said it, that's so accurate because we have to say something is possible by random chance, especially if it occurs. So let's change this. Okay, now Kayla. Yes, Kayla, you did exactly what I was thinking right there. You're right. Like the estimated is key. Like you can't really have a p-value of 0 because things have to be possible by random chance. And so Kayla, that's 50 points for everyone. That is just boom. Kayla just thinking like I can't put 0 because if it happens, it has to be possible, and thus we must have to assign a value to it. So I can't say the p-value is 0. It approaches 0. So that was a pro answer right there. That was because I realized too, because you can always write better questions, and the permutation procedure does an estimated p-value, and Kayla knows from the output we see right here it does say estimated p-value. So this is not the p-value, and since we have an estimated p-value, what do we get then for the p-value? Since we have an estimated p-value, we get a what for the p-value because we're estimating it, and we get a what for the p-value then. We get an estimated p-value, and since we're estimating it, we also make a what for it then. This is key, and this is hopefully connecting the concepts. Since we have an estimated p-value, we're estimating it. We also get a what from, because we're doing an estimate, we're saying, I think this is the p-value, but... So we're estimating it. An interval, yep. And then what happens if we were to have even more? So if we were to have even more, so here's the results right now, but if we did even more permutations, our interval would be water. Like if we take even more sampled permutated results. If we do even more permutated results, oh, it's waiting for the y, isn't it? No, wait. No, it is. It's just running it. So now look at the interval here. It says the p-value is probably contained in the interval 0.0001. Yeah, exactly. A tighter, smaller interval. So if you were to have more permutations, like 5,000 permutations versus 1,000, you get a better estimate because you're doing a more accurate. Yep, that's a great way of saying it too, Ali. Because you're saying we're going to do 5,000 like guesstimate results. Or what if we did 50, like we randomized the results 50 times to estimate the p-value? Then we would see a much wider interval. If we only did 50 estimates, like 50 permutated results, the interval is going to be much, much wider now. And this is the way it works with 201 with sampling and creating intervals. If you only did 50 estimated results, your interval is going to be way, way wider versus 5,000. So there's the interval with 5,000 estimated results, and here's the interval with 50 estimated results, and there's your interval. And it's very inconclusive, way wider, exactly, because you have more uncertainty, because you're only basing your interval on 50 estimated results, and then the p-value is going to have less precision to it, less decimal precision, because you could only get p-values of 0.02, 0.04, 0.06 because you're doing 50 permutations. So really great review. Awesome stuff right there, 320. Hopefully these concepts are making more sense. And we don't want it to look like ours doing just some, like magic in the background. We'd be like, okay, how's it getting that p-value? How's it doing this? We're not going to compute the medians test, but we know it's just trying to figure out if this difference between the medians is likely by random chance when we look at the p-value. So excellent, excellent work. And I think Ali found the f-statistic interpretation. We're going to hop over. We're going to do the notation for 201. So good review for some 320 right here. Let's do the notation. Okay. So over here was actually wanting for the all correlations write up. What do I want again? Sorry, 2 seconds. Look at that. What do I want? I don't know what I want. That's task 3, right? Oh, just go through and mention like the top 5, I think. You'll see it shows it. Don't worry. This is not a grammar class. It's all mathematics. We care more about that. So what is it? Cognates? I can't think of what the words are called when they're spelled differently but sound the same. So go through the top 5 results you have and just mention how they work. Not how they work, but mention the top 5 results and mention like this was correlated with this and found a p like this. Some Britney Spears right there, right? So you'll get top 5 results and then just be like, the top 5 correlations were blank with a blank with blank. Yeah, I would do that. It shouldn't be too much. It'll be a little bit repetitive. You don't have to go into too much detail. It should, just kind of mention things, mention p-values. You could say it was statistically significant. Wouldn't, if you get a correlation, you could say, the top 5 results were correlation of this with a correlation of this that had a positive correlation of blah, 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 and was statistically significant with a p-value of blah, 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 blah. It's going to be a little bit repetitive. I should have maybe done top 3. Like now that I think it over, I'm like, it's probably been just fine to do the top 3 because, it's going to be a little repetitive. So yeah, you're welcome, Kayla. Great question right there. I should have done top 3. Like as I think about it, because if you can do 2 or 3, you can do 5. So, yeah. So Sarah, everybody right here, we're gonna do some population versus here. Let's do this. Let's make 3 lines. So Brian, I'm lost in chapter 7 times. I've looked at the past soft hours and could find it. Yeah, which one, Maddie? Which one are you working on? We'll do that next here. You got it. Which one are you working on, Maddie? We will do that next here. Someone was asking about so whenever we do the Greek symbols, yep, we're going to talk about the Greek symbols here. I think, was it Miranda, did you ask about that? Sorry, we talked 320 for a good bit, and then we're going to do the symbols right here. So whenever you do the Greek symbols are going to be population. Greek symbols, I always think about the Greek population and the sample statistics, small sample statistics. And so you're welcome, yeah. And so let's write down mean right here. I think mean is the easiest one to remember because mean is what? Like it goes along with mean. Like mean. What is the population mean? So whenever you see this, it'd be the population mean. Kind of, we'll show how to connect them in here in a moment. But whenever you see this, it'd be population mean. And think of like mean. So whenever you think of mean, population mean, what would it be? Population mean. Mean something. Mu. Exactly. That's mu. And so then the sample is going to be, we usually use y bar, but it's just a bar over it. So you could like, I guess like any of these right here mean the mean of that variable. So we don't really use these other ones. We only really use y bar, but any of these would work right here technically. Well, we'll do standard deviation next, but so x bar is the mean of the x variable, d bar is the mean of the d variable, c bar is the mean, c bar is the mean of the c variable. We don't use those letters. Good afternoon. Good to see you, Roderick, right here. And we have mu. And so mu is population mean. Now, here, let's do another one. Probably the most important ones right here are mu and sigma. And so when you see sigma, what do you think about with sigma? Hey, Connor, so good to see you. Hey, Connor, if you want to swing by 320 today and give a pep talk, I'd be all up for that. I don't know if you're working or busy. You're here to learn. You know everything, though. You know more than me. You know so much. You know Power BI. That stuff you showed me. This awesome standard deviation. I can't spell. One talks about finding the correlation between. Yeah, let's do that next here. You got it. Passing fire. What time? Let me look at the time on the 321. If you are busy, do not worry. Do not worry. I think it's way later in the afternoon. And then we're going to review the rest of the... Oh, so let me write this down while we're doing it. S. Sometimes we put here S sub X. That's just the standard deviation. And it's lowercase s technically. I don't want to look like uppercase s's for a moment there. These are lowercase s's. It's so funny. Emil Williamson, really awesome. He's PhD, Dr. Williamson now. But one time we were doing a review, it'd be 6:10 your time. 6:10 your time. If you're busy, do not worry. It'd be 6:10 your time. Whatever. You honor me by saying that. So you really... Connor was talking to me in Discord, and he was saying how his skill set, like he felt after 474 was really there, and it just takes time. It just takes time. Like 320, like you start building it up. You're off work then? Yeah, if you want to swing by and just give 320 a real quick pep talk at the start of class to tell them, because it's tough. Like the first few assignments, like you were saying, we were talking on Discord, are tough. And if you're weathering through those first assignments, like Connor, how much easier do you think it gets? Like there are a few people watching right now. They might still be watching. Like Kayla and Allie are 320 students, but it does get way, way easier. It gets way easier. I'm trying to think of. So let's see here. That stands for regression coefficients. I'm going to get an email of somebody. Can I send this to Tool One? I need to make it look better. Yeah, I need to make it look better. I'll probably put it in a table. I could probably post it, Alexander. Regression coefficients are going to be like B0, B1. This is also important for 320. I have to do 474 in the fall. You could, if you can do it in the summer, it's a huge learning curve first, but then it gets much easier. Yeah. So many people told me it gets way easier. They're like, I've had people by the end be like, Brian, this is so easy. Like, I've had students be in 474 and 470, just 475 and 477, and probably peaks mid-semester. Yeah. So we're reaching that peak right now, I think, where it's like, okay, this is getting really tough. And then it just gets very repetitive. Like, you're like, wait, I'm doing the same thing. I'm doing the same y tilde x comma data equals. And we're trying to mix it up. And also with time series, which Connor's going to be helping me design that course a little bit with the material, at least. So we're kind of like Brian, I'm not, he's just going to be like, I'm going to be bouncing ideas off Connor, and which I already have been. So thank you, Connor, as I design the time series course and incorporate more ggplot, dplyr, things like that. So we're probably going to have segments on dplyr and ggplot and plotly and all that. So, so let's hear. I think what else? That's the only one that really breaks the mold on Greek letters. These are beta right here. Is beta with a, how do you spell beta in the Greek words? How do you spell beta with Greek words? Is it B-E-Y-T-A or B-E-T-A? Greek letter beta. It is B-E-T-A. To draw it nice and neat there. Beta. That's good enough. That's how it looks. It's beta. Yep. I think so. There we go. What else is there? So this one is the sample size, or the population size, is the only one that breaks the mold. Be careful. This right here is not the capital N that we think of when we think of normally distributed. So this is not normally distributed with a mean and a standard deviation. So this is not this association. Don't associate it with this. This is not the same thing as this. That stands for, that is not the same thing as that. Does that make sense to everybody? Like, The capital N right there stands for normally distributed. It doesn't stand for population size. And whenever you read any of these off, I think for tool one, I think this is all we've covered so far. We have observation, which is Y, which doesn't fit into any of these because that's just a singular observation. But so okay. Love it. Everyone's working together. Correlation. I gotta remember how to spell row. We don't really use row. There's correlation with Brian's horrible handwriting. Correlation is R, and so that's sample correlation, and row I think is P. So I'm just gonna check right here. Population correlate. It's row, but row is P. I never use this. Yeah, it's denoted as P or R. Oh, it can be capital R. That's interesting. So that is row right there, which is capital R when it's. I never use it. So the main ones you should know. Let's highlight them. You should know this. Should know this. Should know this. These. There we go. So, not Greek. So I think this is a really good review right here of the notation you should know at this point. I guess additionally, we could just add in a breaks the mold thing. I think, so we have here Z, which is Z-score. Should know that. Z is a Z-score. Oh, and then we also have E, which is residual. And Y equals observation. So I think this is, how come I feel we're going to need to know all of this? No, you won't need to know. In 320, we talk about beta, B0, B1, or beta 0, beta 1, beta 1. You don't really need to know all these. Z-score is observation minus mean divided by standard deviation. E is residual E. And Y right there is the observed value of Y. At this point, this is what you should know. We don't really talk about population size much because statistics is about samples, and we don't do population correlation. So we don't need to know these. The better you know these, the better you'll be. Like, what is B1? So you should know what B1 is. It's definitely helpful, like knowing these instantaneously. Like hopefully everyone knows, because we've been doing this lately, what B1 is, and then we're going to do the question about, are you on Ethernet this times? Sorry, I missed that. Connor said that earlier. What is B1? When we talk about a regression model, B1 is what? It's a regression coefficient. Yep, Connor knows it there and stays late. And then B1 especially is the what? Usually, exactly, and B1 is usually the slope. And so technically, because maybe Connor's thinking because you could have indicator regression. And so good job, Leslie and everyone. Excellent work. And it's a regression coefficient, and it's going to be a sample regression coefficient from a sample, because beta 1 would be the true slope of the model, or the population slope of the model. So B1, and so especially for Kayla, we'll be doing this next week when we do a regression, you will see beta 1, which is the true model. So the true model will have a beta 1, but the sample model we get from our estimates will have a B1. It's this, I'll mention 320 here just briefly. The regression model in Stat 201 is as follows. It's y hat equals B0 plus B1 x. And then in 320, it's the mean of y given some x. So mean of y given some x is equal to beta 1 plus beta. Wait, what am I doing with these 1s and 2s? Beta 0 plus beta 1. I like making my betas look cool. And there we go. X1 plus some error term. And yeah, and then the error terms are normally distributed with a mean that is 0 and a standard deviation that is constant. We'll go over this way more in depth in 320, talking about what this means right here. So, and my x looks too small, looks like subscript. Oh, and Connor's talking about how to find, with indicator regression, how to find the 50-50 breakpoint in indicator regression. So, and then the multiple regression model, the canvas on, yeah. How are you supposed to find R? Let's do that next right here. Remember this, my 320 friends? Yep. The negative intercept over the slope. When we do indicator regression, that's how you find the 50-50 breakpoint. And so lots of good stuff right there. This looks super complicated, but this is something we talked about in 201. So the residuals are supposed to be what? Real quick thing here, then we're going to switch topics. I see Avery's got a great question. I think we'll do Avery's next, and then we're going to go to the other one here. And so let me look at the Canvas content thing. So we'll do Avery, your question next, then we're going to hop over to chapter 7 next right after this. So what does this mean about the error terms in the true model? So 320, 201, what does this mean about the error term in the true model? So 201, you should have some, so you're going to help out 320 here with this. What does this mean about the error terms in the true model? Exactly, Connor, right there. They're normally distributed, and the mean of them will be where? So yep, Maddie, exactly. They're going to be the error terms in the true model. That's the error term. Will be normally distributed, and they'll have a mean of 0, and then they have a standard deviation that's constant. What does it mean to have constant standard deviation? 201, 320, you should both know this. What does it mean to have a standard deviation that is constant? If you talk about the errors in the model, which is the residuals, so just think of that error term as just the residuals. Which of these has an error term that is constant? So when we say it has a constant error term, well, good, Carrie, you're so close. So this, let me make this clear. This one right here is dealing with the error term, and the error term, in one of those, it's constant. Yep. In graph 1, the error term is constant. So, no, you're right, Connor. Graph 1 has a constant error term. And then let's look down here, because Kayla, you just hit upon something else, and you're way ahead. We're going to switch topics here in a second, but this one has a mean of 0 the whole time. The error term has a mean of 0. And this one has an error term that does not have a mean of 0. And what do we mean a mean of 0? The mean of 0 for the error term means that we meet what condition? So if the error terms, you're on the right track, Alexander. So look at the first one. Look at everything up here right now. I'm going to underline in red. Look at this. And these two things, this will come into play in 320. So we've got a blue and a yellow. So the mean of 0 and the standard deviation being constant, what conditions does this remind you of? This will be big for 320. I put this on your exam for the second exam. I think, no, it's not. This is first material exam. This is very last material for first exam. This is the very end of where we'll get to. So what do you notice about, like, look at this regression model versus this regression model. And this one has constant standard deviation. This one has a varying standard deviation. So 201, this is a good review for chapter 7 because you should notice a big problem here. 201's got some words for it, and 320 has some words for it. So what do you notice right here, 201? Like when you see this plot, you should be like, oh, that's got a big issue right there. And here's the mathematical way we look at it. By saying the error terms do not have a constant standard deviation. Well, it is a correlation and regression. And so the error term, which is the residuals, how far it is away from the model, exactly, Connor's pointing out, there's some plot thickening right here. Does that make sense that in this one, the plot stays the same thickness? In this one, the plot gets thicker throughout. And so this one has homoscedasticity. This one has heteroscedasticity. Now, this first one right here, the mean being at 0 means we meet the what condition? Exactly, plot thickening, exactly. And I guess I'd accept it. You should just know what heteroscedasticity, like, don't worry. Like, if someone said the plot thickens, I'd be like, yeah, it's a big problem. But if someone says heteroscedasticity, then I know they're a stats person because it's heteroscedastic right here. What do you notice the problem for this one is, Kayla? In the bottom one, what condition do we not meet for regression? What condition do we not meet for regression? And actually, you know the normality, just to bring this full circle. Can I shrink these down? The normality one is going to look like problems. If we were to say there's problems with normality, that's probably due to what? That's the wrong color. Yep, straight enough. That's the straight enough. The blue one's the straight enough. Problems with normality is probably going to be due to what? So we're doing the good one on the left. It's all good regressions look like this. And if you get a good regression, you found something special because they are not that good. So problems with normality is probably due to what? Problems with normality is probably due to what? And this one's like good all the way across. This first one's like always the good one, and the second one's always the bad one. Outliers, yep. So if the residuals are not normal, then there's probably, and the residuals are the error terms, like that's the true error terms for the model, should be normally distributed. So if you look at this, in this notation right here about the error terms, you actually see like we're checking for outliers. You see we're checking for the linearity condition by saying the line is centered at 0. And then, oh, but it is. But wait, Alexander, let's throw 20 points right there. Alexander, great comment. Because it's a scatter plot, scatter plots can only be made from what? Scatter plots can only be made from two quantitative variables. So when you have a scatter plot, you must have two quantitative variables. Does that make sense? So good question, good comment right there. We always have to make sure to start that it's two quantitative variables. And since we have a scatter plot, it is two quantitative variables. And then we've got some tricks for indicator regression. Let's look at the question people were asking about for the canvas. And remember, tool one disappear for the moment. But tool one, here is all your notation. I've highlighted what you're responsible for. I couldn't think of anything else for the test. Please, 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 if you're thinking about it as I load up the Canvas content quiz at the moment, if you think of a notation we should know, let me know. And I'm logging into Canvas and class not till, we got a lot of time. We'll get that second cup of coffee here in a little bit. Wake up. That's what we got to do. Let's go look at the Canvas content quiz. We're just going to yawn. Okay, Canvas content quiz number... Only number 4? Oh, we're good on that. I made changes to this and I didn't save it. Okay, let me see. I'm trying to find the output right now as we talk. Let me talk about this briefly. Was it so I think is the person still here who was asking about the Canvas content quiz? I think it was Avery. Love Whiteboard, awesome. Is Whiteboard an app or something? Because maybe I need to use it. I just want to be able to annotate on my screen. Like I can't annotate on this screen right now. Like I'm just moving it with the pen. I wish I could just annotate on it at all times. Well, this one just asked us what is the R squared, and it's going to be, that's cool. That's the R squared right there. That's where it says R squared. This one down here says, if you know the R squared value, to find the correlation, you would do which of the following? And this is a really good question. All this good, all right. I love everyone helping everyone out. So whenever we find correlation, like if you were, this is a good one right here. If you were to find the correlation for this. So, oh man. Oh, you're right, Connor. Now I missed that. I missed that so much. I think we don't have output up from yesterday still. I'm gonna pull up some jump real quick here. Whenever you find, we can pull up this, I think. Cool. Yeah, let's do that. And Maddie, you had that next, right? Let's do that next, Maddie. You got it. Let's look at, oh good, I think age and GPA. Okay, so here's a really good question for everybody. That's major problems with, what is the problem with this plot? Good test question right here for 201 especially. What is the problem with this plot? What is the problem with this plot? We should know pretty instantaneously. This one has a huge problem with something. This one's like, oh, that's bad. That regression's just horrid. Textbook quiz. It doesn't give you R, so you can't do the linear model. Which one? Yeah, huge outlier. Which one? Can you paste part of the question in here, Avery? We'll hop over and do it next here. We're gonna do Maddie's question. I think she was wondering about. I might have to, if you can mention which one it is again, Maddie. You mentioned it earlier. because I'm asked 2 questions on this. Huge outlier, definitely. Now here's a test question that we put on the test a lot. So this is a test relevant question. What is going to be the correlation here? Yep, definitely. There's 2. Great job right there, Alexander. Let's throw another 20 points. What is the correlation for this? 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 So take a moment and find the correlation, even though correlation does have a problem of 2 outliers, which is conditions for regression, QQ straight enough, no outliers. And we don't really have issues with other things. It's mainly straight enough. But what is the correlation? Alexander, you're on the right track. That's the thing we're going to have to make sure we note. And that's where people make the mistake usually. So what is the correlation? I don't want to find it quite yet. Let me type the R squared. This is where people make the mistake. There's a very common mistake that I want to point out here. Very, very common mistake. So I don't want to find it. I want you to find it. I want you to practice right here and make the very computer software says R squared equals. Yes. I think, Maddie, yep. This is very similar to the one you're doing. So if you have R squared, what do you do? So Maddie, this is perfect question, Maddie, right here with this. So something with R squared, yes. So if we have R squared, how could we get correlation right here, which is R? Take the square root. Great job right there. Good practice. This is also in 320. We're going to take the square root of it, but then we have to note something. So Alexander was pointing out something. Is the correlation here 0.929? What does this represent right here with being 0.29? So be very careful. This says 0.29. What must we note? Because it says 0.29. We have to know something, though. We have to look at that, and price and age works the same way. They're right about taking the square root. Yep. There, Maddie, yep. Put it in decimal form, take the square root of it. But then you must always look at what next. Alexander points out this is negative because it goes down. So always note the direction, which is also on the Canvas content quiz. When you look at what it says, that when you, so if you know the R squared value to find the correlation, you would do it to the following. Take the square root of R squared and then check the direction, the scatter plot. That's the only one we're going to check right here. Let's change that. Submit the quiz. We're going to do a horrible job, but we got 1 question right. Woohoo! Wait, where's the our score? Do we get to see our score? Yay, we got it right. So you have to make sure to check. I was like, if we didn't get that right, I'd be crazy, confused. We got a 20%. But Maddie, so that should help out with that one, Maddie. Does that make sense? That's how to find the correlation from R squared. You must always take the square root of the value. And we did a little Canvas content quiz help right here. You must always take the square root and then check the direction of the correlation to see which way, is it positive or negative. You could also alternatively check the coefficient. So we could have looked at the sign of the coefficient. So the sign of the coefficient in the regression model for the slope. So you could check the coefficient of the slope. So this is B1 right here. B1 is negative. Just so everyone can see, let's grab the regression model. And I think we're going to jump over to Canvas content quiz. So here's the regression model right here. And you can see that's just the name of the variable. We're just call that age. The coefficient is negative. The square root of 893 is 0.945, but it marked. But wait, Maddie. Oh no, Maddie. But why might it have marked it wrong? Why might it have marked 0.945 as wrong? Can you disable Spearman testing with the associated? Can you? You might be able to. Do you want to do that, Connor? We could recode it. We recoded it. So once you take, so a big thing is once you take the square root, what must you do? Like once you take the square root, what must you do? Once you take the square root, so we go here and we say, okay, we have the R squared right here, and now we're going to square root it, and then we're going to see if it's positive or negative. So it goes down, and the coefficient right here is negative, so we're going to make it negative. Does that make sense? So I could disable the Spearman if you want. Connor, if you want, just email or just Discord me, and I'll send you the associate command with the disabling of the Spearman if you want that output removed. We recoded all correlations yesterday. We made all correlations too. I think I've still got that saved in here somewhere. We went in and we added an additional argument, so I'm sure I could do that. My question doesn't have a chart like that. It has output, right? I think I'll pull it up. It has the output, which we can bring over to jump, But also, it should show that cars that are older are selling for less. If you look at the prices, I think I know how this question looks. It's got a chart to the left. If you look at it, you'll see the newer cars are selling for more, and the older a car gets, the less it sells. So the more years older a car is, the less it sells for. So there's a negative correlation. So it is a little tricky in that regard that you don't get to see the chart off the bat. I wish they just showed you that. But you have to make the output to see it. So like, aha. Or if you know the question. Let's go over to the quizzes. Chapter 7 quiz. Okay, we got it up. There we go. Great job working on this early. I assume it has to do with the spearman because there are ranks that are tied. Oh, I was messaging someone and I think it was throwing an error about the exact people. Yeah, that's what it is right there. And it's a warning message. So one way around that really quickly, Connor, is around it, just put suppress warnings. And then you can do the associate command. So if you're getting that, just put a suppress warnings around it, and that will stop it throwing all those warning messages saying warning, 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 tie rank, tie rank, tie rank, tie rank, tie ranked. So just throw a suppress warnings around it, and that should fix it. Or we could find a way to disable it. That'd be fun too. It's more. I find it more fun to like go in and recode Dr. Petrie's work, or maybe you could just turn off the warning message. So 2 seconds, and then we're gonna do the. Okay. I hate that. Scroll up. There we go. I could Discord you this, Connor, in a second. Okay. Associate 2. No. There we go. There's the function. Oh, no. You know what it is? It's whenever it does the spearman, it must be generating the warning right here. So maybe if we you might be able to put a suppress warnings around these, Connor. Like, I'd put a suppress warnings around these, or yeah, you could. I don't know if there's a global way. I don't know if this would work. This might work right here to put a suppress warnings around this. So when it runs it and stores in that. But anytime I see... This could possibly work. I don't know. I've never edited the function like this with the suppress warnings there. But that might be the only time spearman is used. No, it's used quite a bit more around here. Yeah, it's... I was... So it looks like it's a warning. I don't think there's an argument to disable spearman. I wish there was. We'd have to put in like an if. Like if someone says spearman equals true, then run this code. But that also might create issues with the output. So little more editing than would take a moment right here. Let's look at that car question right here. And then 201, any questions you have on all of these, let me know. Let's take a look at that car question. So where is it? But suppress warnings will fix it. And then I'll try to find a way to... Here it is. So when you look at it, here's the oldest cars. So the oldest cars are selling for $1,000. I mean, man, I'd love to... What is that? Like a 2008 car right now for $2,000? Is that what they go for? I don't know. And then here's a brand new car, or a car that's 1 year old, I should say. And it's going for $13,000. So as a car gets older, we generally see lesser prices. So just going off theoretically, we don't have to plot it because we can take the value of R squared and we can square root it. But as we see cars getting older, the age going up, price is going down. We should know that this is negative right here. So we should know that that is going to be negative. And hey, Brian, can we ask questions regarding BS28? Yeah, Thacker, go ahead, ask. Yep, we'll circle back to it here at the end. We're gonna do a little 201. We did some 320 at the start, though. Definitely check it out. Explain the R squared in context. So 89.3% of the variation in the price of a car is explained by the age of the car. So age accounts for that variation. The correlation between cereal's age, oh, you got it. Let's do that next. And what does this mean, or why is this way? It's probably other factors. There's other things that account for the variation, not a simple model. The correlation, let's go look at that one. I think that's question number 3. Aha. What fraction of variability? So when it says fraction of variability, what value is it talking about? If you see fraction of variability, what is it talking about? When it says fraction of variability, it's talking about the percent of variation in y explained by the variation in x. So when it says fraction of variability, what should you think about? So it's not saying it the exact way I say it. I usually say blank percent of the variation in y is explained by the variation in x. What concept are we talking about here? We're talking about the amount of understanding we have in the y variable based on the x variable. Like the x variable gets us this much to understanding y. So if we're talking about that concept, awesome, Connor. Thank you so much, Connor. I'll have you jump in, give them a little pep talk. I really appreciate that so much. I'll send you a quick. I'll hit you up on Discord. You can come in and like 2-3 minutes, just be like, I don't know. I want them to know they got this. So when you hear fraction of variability, what concept do you think of? We're talking about the percent of variation y explained by the variation in x. So blank percent of the variation in y is explained what concept is this? What concept tells us blank percent of the variation y is explained by the variation x? R squared. Nice job, Kirsten and Leslie right there. Excellent work. Let's throw some 20 points in the chat. This is R squared. Blank percent of the variation in y is explained by the variation in x. And this is going to be R squared right here. R squared percent of the variation in y is explained by the variation in x. We always do it in context. Exactly. Blank percent of the variation in y. So it's saying it a little bit differently. It's saying what fraction of the variability, which is variation. So what percent of the variation in the one variable is explained by the other variable. We're just going to take this R right here, which is correlation. We're going to square it, and then we're going to copy, and then move around our decimals. So just some moving arounds of decimals and some copying, and that should do it. Did we get it right? We got it. There we go. What was there another question? Which other ones? I think I may have just missed this in class, but you explained task 1 on some of our. You bet. Yep, we'll go back to that here in just a moment. Thacker, you got it. So what other questions were there on 201? This one's a tough one. 201, start this early and ask questions. We will have afternoon office hours too. You got it, Maddie. No, good questions. This is good practice. So understanding when you see R squared and correlation. And so it gave the correlation, then it basically is saying find R squared. But it just describes it instead of saying this is R squared. So it doesn't just say find R squared from R. It's saying find the fraction of variability. And so it's describing what R squared is, which makes it more confusing. So they're like, you have to know what the concept means. Which ones did we not do yesterday? I think we did this one. Let's see, 201, this is your opportunity. Be like, Brian, I am stuck on this one for Chapter 7 quiz, which we did a good bit of them yesterday. I'm having trouble finding R so that I can begin formulating the B1 using the... yes, Avery, you're in our section, right, Avery? If you're in our section, the best thing to use right now will be the regression solver. Which problem are you doing? The GPA one? Or are you doing the standardized score ones? Which ones are you working on right now? The best thing right now is if you go here and you grab the regression solver. And so go to, which one is it that you're working on? You can put GPA or standardized test score. Which one is it that you're working on? And I'm getting the Regression Solver Pro from modules. This is under the thing I'm downloading. Oh, both of them? Okay, cool. So Regression Solver right here. This is under the modules, Chapter 7 module. We're just going to open up the Regression Solver right here. And this does all the heavy lifting for us. So instead of solving these things by hand, we're going to let the Regression Solver do it for us. And so let's go ahead and take a look at one of those questions. And here we go. Hey, Brian, if you had time, would you be able to run through the drug use? Yeah, let's do that one next here. We'll do that one next. You got it, Sarah. And so this one right here gives a bunch of information. And can we take a screenshot of it? Sometimes it's like, no, you can't take that screenshot. We will do that one next. And Thacker, we'll do your question right after this. We'll go over to 320 again. We got this. So let's go ahead and drop this into here. And we're going to bring it down a little bit in size and bring it over to here. Okay. So suppose, anytime, yeah, no, just here to help out. That's what we do. Yeah. Suppose the entering freshmen of a certain college have a mean combined SAT score of 1244 with a standard deviation of 122, and they want to predict. We need to know what the y variable is. This is very important to this question. What is the y variable here? The y variable in this question is what? This is super important for this. What is the y variable of interest? So I want you to tell me right now, because a few people have asked this. They say, well, what is the y variable? So look at the equation, and what is the y variable? Very, very important right here. What is the y variable? So what is the y variable? A few people have emailed me, and one person said, what is the y variable for this one? I'm like, you got to look at the equation. Equation, GPA, nice job, Alexander. Thank you so much. It's GPA. So when we see this is the SAT score, we know this is the x. So it says they have a mean, and this is the mean of the x variable. Does that make sense to everybody? That this is the mean of the x variable right here. This is x bar with a standard deviation of 122. So that's the standard deviation of the x variable. And the GPA had a mean of 2.65. And the standard deviation of 0.56. And the correlation was 0.46. There we go. There's the intercept. And 5 decimals. Oh my God. 1, 2, 3, 4, 5. And then here is the slope. 1, 2, 3, 4, 5. And that's got it for that. Explain what the intercept means in the concept of the regression. It's when someone has a score equal to 0. And that seems outside the bounds of the model. So what it would predict for GPA represents the predicted GPA, because we're predicting GPA. If they have an SAT score, yeah, it's super useful. It's so helpful to Alexander, it's so it's posted right here under modules, chapter 7. It makes life way, way easier. You just put the numbers in as long as you know the notation, modules, and then go down here to chapter 7. It should be under all sections, Regression Solver Pro. So with this one right here, does this make sense, Avery? With this question, let's go look at it again. It gives R right here. So I'm hovering over, it says the correlation. So every single one of them hides it from you a little bit, but scroll up, you should at one point see the correlation, which the correlation is going to be R. Does that make sense, Avery? Every question should always have in some way say the correlation between these two variables. The other question, it's a little bit higher. The other question, you have to scroll up a little bit. They give you all the information, then it mentions it previously. It's like, scroll up just a little bit on the other question. You'll see it says the correlation between the two variables is this. But yep, so all questions should mention the correlation in some way. Interpret the slope of the model for each 1 unit increase in somebody's score. We'd expect their GPA to increase by a certain amount. So yep. The model predicts the freshman, will increase by 1. No. For each 1 additional point in someone's SAT score, the model predicts the GPA will increase by the value equal to the slope. Yep. Predict the GPA of a freshman who had a SAT score of 1400. Here's the great thing about the regression solver. You type 1400 right here, and it solves for the predicted value. So one thing to note, and what's to 2 decimals, and I think everything works properly. All we're doing is taking and plugging 1400 in here for score. So it should solve out correctly. We're going to cross our fingers on that one. Can you post the question right here? We'll take a look at that next, Avery. What does your question say? Post part of the question, I'll find it. Based upon these statistics, how effectively do you think the SAT scores will be in predicting? Probably not very effective because the correlation's a little bit low. Got that one wrong yesterday. Don't tell anyone. As a student, would you rather have a positive or negative residual? We want to have a positive residual because that means we did better than the model predicted. Let's see here, because it would represent a higher, we're predicting GPA score. We should have everything. Woo! I'll always double check. I always double check what I have. I got a little afraid. We went a little more in depth yesterday on this one, so I explained how the residuals work and everything for this because the residuals, because we got 27 minutes to all be teaching, so and I want to do a few more questions here for everybody. Which one is it? I think we have another one we're going to do. Which one's the one with the? Oh wait, we have Sarah's one, the drug use data one. Okay, let's look at the drug use data. Sarah, we said we'd do Sarah's next. And the drug use data, wildfire. We did wildfires yesterday. Use the advertised price. Yeah. I think we did that one just a moment ago. Avery, take a look. I think here? I'll show you right here. Is it? Rewind just a tiny bit because Is it this one right here? Table. Or maybe it's a different one. Might actually be a different one. We're going to find the drug use one if we can. Wildfires. Where's the... Oh, wait, here it is right here. Here it is. We'll come back. This is question 11. Oh, yeah, I think this is it right here. I think this is the one. This is... Yeah, so this is... I think we found it, Avery. We'll try to do that one next year. Run drug use data question using regression. So, yep, here we go, Sarah. This is this one. We got time. We can do these two. We got this. We got this. So, do you think the linear model is appropriate? Yeah, it does. That looks pretty good. So, the linear model looks pretty good right here. I really hope they say it is because, yeah, it's. I'm not gonna say it's weak, and there's not really big outliers. That's fine. That's not bad nonlinearity. Overall, this is QQ, straight enough, no outliers. So I'm going to say, yes, it is positive, linear, fairly strong. We might not have enough time. So I think we did that one yesterday, Wesley. We might be running out of time, but we definitely did it yesterday. So check out yesterday's video and it's timestamped. And if you're stuck, I will be doing office hours later today. So definitely check that out because I'll be teaching here in just a little bit. So definitely check out yesterday's office hours. And if you're still stuck, let me know because we will be back later today. For the regression, r squared is equal to this. Interpret this statistic. A linear model on the percentage of... so they're saying accounts for this amount of the variation. So that's 86% of the variation in what? So you're welcome, Wesley. Thank you so much. So we are trying to explain... other drug usage. So marijuana drug usage accounts for 86% of the variation in other drug usage. It's totally different from the way I phrase it with blank percent of the variation in Y is explained by the variation in X, but marijuana usage accounts for 86% of the variation in other drug usage because we want to understand other drug usage. Write the equation you'd use to estimate the percentage of teens who use other drugs from the percentage of teens who use marijuana. My gosh. This is where Regression Solver Pro is going to save us a lot of time. So let's go ahead and copy this. Regression Solver Pro to the rescue. So make sure to have this. It's super helpful because it's so easy to make errors when working with these. It's so easy to make errors while working with these. There we go. The coming scatter plot shows the percentage of teenagers who use marijuana. 11 countries. Some statistics show that the mean percentage of those who've used marijuana was this. So 24.2. This is the X variable. That's the mean of the X. 24.2 with a standard deviation of X of 16.1. An average of 11.1 had used... Wait. My gosh. Other drug, okay, there we go, the average. So the average of the Y variable is 11.1 and a standard deviation. And we should see the correlation on here somewhere. Oh, so you have to get the correlation from here. So you have to go here and get the correlation from that. Oh my gosh. There we go. There's the correlation. Does that make sense? The R squared. The R squared. Does that make sense, Sarah? Good question right there. The R squared. So the R squared. It should be. Yeah, no. Really good question right there. Let me see if this looks accurate for the model. This is a tricky one. Good question. Haven't done this one a lot. Okay, this does look to be accurate. Yeah, it does look to be, and it is going to be negative. The intercept is going to be negative. Do you see how the red line would go negative here? And that does look to hit about -2. So I think we've done everything properly. To get the correlation, you have to square root this. There's the R, you have to square root it. Just to show that again, you have to square root R squared to get R, and there is positive correlation right here. We know that from looking at this. So we do have that. So we now have our model right here, which is -2.8. How many decimals? 3 decimals. -2.839. And then we have 0.576. Explain in context what the slope for the marijuana line means. The slope indicates that marijuana use increases on average by, no, other drug use increases on average by, my gosh, 0.576 for each percentage increase in marijuana usage. And I think they want it. I'm worried about my decimals, but I think we got everything properly. Does this result confirm that marijuana is a gateway drug? We can't say correlation implies causation. We can never say correlation implies causation. So, no, since the all varies, no. The results do, no. The results indicate an association between marijuana and other drug usage. However, association does not imply causation. I think we have everything correct. I'm worried. I knew it. I knew something would be wrong. The sum indicates that other drug uses increases by 3 decimals. We're good on that. We're just going to do a quick check. That should be right. Oh, yeah, that was right. This is correct. What did I get wrong? This is correct up here, right? Yep, that's correct. A linear model on the percent. Did I click as 86% of the variation? Is this wrong by the tiniest amount? That can't be wrong. Let's change it to something like that. Ooh, that's what's wrong, it looks like. What did it not like about 3 decimals, right? -2.839. So it is the intercept it's mad about. Why would it be mad about the intercept? Let me check my numbers in the regression solver. It's mad about the intercept, and let's look at the numbers. So, mean of marijuana usage is this. Standard deviation of marijuana usage is this. An average for the other drug usage of this. And there. Is it really... Is it because the correlation I carried out to so many decimals and that made it more accurate? I'm going to be so... Is it really going to be that? Is it mad? I think it's mad about how I carried out my decimals, and I'm really not happy with the question for that. Ma Pearson, you are not my friend today. It's this intercept. I'm trying to see... We can't just copy the data, can we? Oh, this is going to make life way easier. Okay. Why didn't I just do it this way? Here, life is 10 times easier. Analyze, fit y by x. We're predicting other drug uses for marijuana. And now we're going to fit the line. The answer to the intercept is... weird. I might seriously contact my Pearson about this. So don't use the regression solver. I need to see something. Analyze. Distribution. The mean is 24 point... Yeah, it's the way they're carrying their decimals, I think. I want to check a few things out right here real quick. The mean for this is 24.18, so that's not carried out. 16.14, that's not carried out decimal accurate. The mean for the other one is 11.09, so that's a little decimal place off. And the standard deviation is that. So what should happen here, and so the answer to the... So you need to solve this one via this method, -2.75. And so -2. I'm just going to put that in and see if it takes it. Yeah, it took it. So you need to solve this one using jump. And I think it's because, and I really, there's things I need to email my Pearson about. I'm pretty sure the issue is that they're not carrying out their decimals. And that really just drives me up a wall right there. So the mean 0909, so that needs to be this, would be 09090909, and that's got that. And then the standard what is that, the mean, right? That's the mean. And then standard deviation is 9.96. I wish I could just copy that. 9.96444. So 9.96444. There's that. And look, it's automatically changing. I need to tell them that if you solve this one by hand, you get it wrong. And that's not cool, my Pearson. You need to put in a second answer. And then this right here, 24.1818. So this needs to be 1818 repeating. And then the other one needs to be 16.1419. So this is 1419. They need to carry out their decimals. And there, look at that. Regression solver is not broken. My Pearson's broken because it was solving it out, but they just didn't carry out their decimal place accuracy. Does that make sense, Sarah? Sorry, I went down a rabbit hole on this one, but it really, I was like, no way. I was like, I did everything correctly. And please tell me if you hit issues like that. People have emailed me and gotten points back. This would be 100% where you should email Brian and say, hey, I did it correctly. I used the regression solver. Frankly, I might even remove this question because seeing this, it's not cool that if you do a proper way of solving it, they don't have, because they give you summary statistics. So if you have summary statistics, you should be able to solve with this. But when you do it inside of JUMP, you get the actual answer they're looking for, which we now have confirmed the same answers. JUMP's just going to carry all decimals out completely to way further than my Pearson would when they're doing their decimal place accuracy. So the correlation, even if we go here and find the correlation, this is why this is the real way statisticians do stuff, is they just solve like that. Here's the correlation, 0.9275, and I bet you this will make it even more accurate. Yeah, now it's 0.2754, and if we go back here, if it had given us all the decimals, there we go. So had we gotten all the decimals, it would have worked 100%. These are not properly decimal formatted. Sorry about this question. So big note, please do this question in JUMP. I'm going to do it one more time here really quickly, and we'll probably have to head off soon here. Thacker, we did, I think yesterday we did assignment 1, but I will be back later today, Thacker, so I will handle that question at the start. And I think we had one more 201 question lined up. But you copy the question to clipboard, copy it here, go over to JUMP, and in JUMP, go to a new data table, file, new data table. In the new data table, you need to paste with column names. Pasting with column names, go to Analyze, Fit Y by X, double click, or we want marijuana to be up there or down there, because we're predicting other drug usage from marijuana. Very important that other drug usage is at the top. Click OK, and then go to the red arrow, go to Fit Line, and we now have the regression output, and this is accurate. I think there was one more. Let's try to do the one more. We got time. There's always time. There's always time. Let's do it. My Pearson, how dare you? Okay, so this one, yes, perfect. This one right here is another JUMP one. Yes, we love the JUMP ones because we can go ahead and copy to clipboard. We're going to copy the data to the clipboard, and we're going to go into JUMP, and we're going to go to File, New Data Table. Very important that you paste with column names right here. So when you're in a new data table, File, New Data Table. Go ahead and do this. Make sure. Yep, and then, so is this making sense right here, Avery? It should be on yesterday's office hours. Thacker, email me if you can't find it. And I have it segmented, like, so I put the timestamps on there, so it'll be me walking through it in yesterday's office hours. So let's go to here, Analyze, Fit Y by X. We're going to predict the price by the age of a car. And there's a little bit of nonlinearity right there. Yep. Is this making sense right here? Oh, I think I said that that's nonlinear. Little dip in the model right there. But we have here the full model. So I'm probably going to have to end this right here because I'm teaching in 12 minutes. But does this, Avery, does this get you kind of the next step on this question? Because from here, we do have the regression model now, and you should have the slope and the intercept. and we should be able to make predictions for a 7-year-old car, and we should be able to talk about the residuals. So I think the stumbling block for this question would be getting the regression model, which we now have the regression model right here. So we have the price of a car, and then we have the intercept right here, which goes here. Nope, you don't need to include the lack of it. Good question right there. Or the analysis of variance. Yep, good question right there, Ben. This would be your output. Like if we were including this for visualization number 5, we'd use output like this. You're welcome, Avery. Thank you so much for hanging out. Lots of great questions today. Great office hours. That does it for now. Let's head back here to space. Turn on our just chill music. Random question from Andrew. Is it allowed for one teacher to put a test on lockdown versus not? As in what, Andrew? I'm trying to understand. So no variance either? Yeah, you don't need the analysis of variance section. No one should count out for that because we're not doing an analysis of variance. It's allowed for one teacher to put tests on lockdown versus not using lockdown. Like one teacher uses lockdown and another one doesn't? I think so. It might be tough because, we try to keep to the same standards, especially if we're teaching multiple sections, but maybe one teacher definitely talk to them. Communication. Feel free if you want to tell me more specifics or ask more specifics about it. We can definitely talk on Discord. I'm going to jump off here in a moment, but woo, good office hours. Tons of questions. Love it when we have like everyone in the chat talking and asking questions. A lot of 320 help. I'll put some timestamps in the video later, and we'll be back later on. Oh my God. Oh, wait. I've got my annual review tomorrow, and I thought it was like now. I was like, wait a minute, I'm not getting reviewed right now. But with that, everyone, Mubot, you good?
I am Mubot.
Yeah, you're Mubot. Everybody, bye for now, everybody. Bye. Bye, Andrew. Bye, Ben. Bye, Avery. Bye, everybody.